is legitimately. Anyways, an acidic solution means that there's going to be excess hydrogen ion present.
Should ignore us, like.
What?
Right? The acid acidic solutions in general, just as an example, if you had HCl, that's going to dissociate into the hydrogen ion and the chloride ion. This is the phase states. So when we say in acidic solution, we legitimately mean the hydrogen ion is doing something to help carry the charge in the solution. That's important in redox chemistry because electron buildup is not a good thing. So there's going to be a couple steps we follow. We're going to separate into half reactions. And by half reactions, we mean what's oxidized, what's reduced. Once you do that, you're going to balance all atoms except hydrogen and oxygen. Then after you balance those atoms, do you have to do it in these steps to a certain point? And then after that, you kind of have free reign to mix things around. So far, you need to be in these orders, or this order. Once you do that, we're going to add water to balance the oxygen. And then after that, we add hydrogen ion. So this is the acidic solution part to balance the hydrogen. Now, starting at this point, we can kind of play a little bit, but not too much in terms of what we do. We're going to balance the charge by adding electrons.
Yeah, there was 2 of those around my desk earlier.
Yeah, did you eat them?
No.
Crunchy.
Did you eat them?
Yeah, one did the pipe one time.
Too small to be crunchy.
But that's what you think. Their exoskeleton is legit. You get stuck up there in your tooth and you gotta floss it out and pull out the wing 8 o'clock at night.
I don't like that you actually know that from experience.
Same. Not so bad of a flavor.
Does one say separate into half reactions?
Yeah. Balanced charge, adding electrons, combined half reactions. I don't know, what do you say here? Cancel stuff? Can I say stuff? Because stuff could be anything. Ions, molecules, etc. Let's say cancel
Substances, so elements, atoms. You could use a lot of words.
similar
Compounds.
quantities
Okay. That's fine.
and identities. I could stand up. Ah, okay.
The sizes of these ones.
Yeah, okay. Now, if in basic solution,
Hold on.
draw a line there.
Hold on.
Hang on.
He said, he's like, alright, let's.
When we're talking about basic solutions, we're talking about the hydroxide ion. So something like, you don't need to write this down, sodium hydroxide dissociates into its respective ions. This is the basic component. All right, so in basic solutions, do all this, but then at the very end, go ahead and add hydroxide ion to balance the hydrogen ion present.
You spelled
Cancel,
quantities
balance.
wrong.
What's I say?
You
What?
said quantities.
So when you said quantities and identities, quanties.
I mean, same thing.
Quantities?
There you go.
Thanks. What did I spell wrong yesterday?
Something.
You know how I do it? If I know I'm getting ready to spell a word wrong, watch.
You just were, yeah.
Yeah, no, that's accurate. 100%.
That's like you can't really make it out, so you spell it how you think it sounds.
Well, then we have to ask you what it says.
Yeah, but then I'm like, oh, that's just commitment, you know. And I'm like, yeah.
No, but like you're not even wrong, and I hate that.
I like to be self-aware.
Yeah, right.
To cancel H plus and form H2O.
You just threw the board.
This is,
Yo, now I can't see it.
yeah,
Right.
this is what's gonna happen at the end.
Well, now the sink's in the way.
And then
No, it's still in the way.
Oh.
There's still a sink
Put
there.
it, there you go, right there. It's Rachel's not in the way.
He just overlooked it. He actually
Now
adds
you're
more.
in the way.
I know. I've been doing some push-ups.
No, you
No, you haven't. She's like, what? That's so
Man, that
fast.
is hard.
I just really said no.
Actually, I do like 5 or 6
What are
in the morning
you-
just to wake up.
Can you? She literally said it was perfect space,
I
and then you
tried.
moved it.
I still can't. There we go. Leave it right there.
Oh, I thought that said storm. That's form. Oh.
It is.
Prime example, right there.
How do you storm
Right
H2O?
there.
What?
Where? This?
Great.
Form.
It definitely looks like an S though. Like I see it. No, I see
read
it.
what I wrote. I was like, wait.
You have to
What
make
is
it
this?
rain to cancel the rain.
What?
Don't worry about it.
No, it was more for us than
Okay.
you.
Alright, so then do that. But we could also remember, I'd say kind of here, squiggly line, you can kind of mix and match. You don't have to follow in this order. You could kind of do some of this before, some of it after, and you still get the same results. But up to this point, it needs to be pretty much the same thing. Alright, let's try number 1.
Separated? Yeah.
Now, what was behind that board that you wanted us to write down?
Hydrogen plus hydroxide yields water.
Hydrogen plus hydroxide.
On most of these problems, you're going to need a good amount of space, even if you're doing it in your notes at some point.
Good
So just
night.
look it up.
Oh, okay.
What number
Alright.
is that?
This is number 1. Let's try it. So it's an acidic solution, so we'll be able to stop and not have to do anything else here. How do we know it's oxidized? How do we know it's reduced? Because that's our first step. Go ahead and separate into the individual half reactions of what's oxidized, what's reduced. So we do know iron is oxidation state of 0. It's by itself. Over here, we know it's going to be positive something. So at minimum, even if you didn't know how to predict oxidation states, is that oxidized or reduced? Going from positive to 0. Positive to 0. We're adding electrons, so that's a reduction. So we at least know we are going to have Fe2O3 going to Fe.
Do we need to balance?
We will need to, but that's the next step. And to your good point, actually, let's answer that question first. Do we balance the molecular equation? You can't initially because there's this thing, and that means there's somehow hydrogen ion present. If there's hydrogen ion on there, where is it at in the reactants? Oh, there's also hydrogen ion in the reactants, but to what extent? So therefore, we have to go through this process to be able to balance the molecular equation.
So we have to go in and add all the other stuff just because they didn't add it?
Well, it's more like, not necessarily spectator ions, but the hydrogen ion is helping do something with the charge of the solution so that redox can actually occur.
Even though the hydrogen doesn't appear anywhere. in the
Right, but
formula?
that's because it's overwhelmingly in the solution. It's on both sides. Both sides.
Okay.
Yeah, if you just have a beaker and you throw stuff into it and reacts, then hydrogen is both in the reactants and in the products. It's everywhere in the solution. And then what's left over would be and give yourself some space here. Carbon monoxide and carbon dioxide, okay? I'll write these out individually as step. You don't necessarily have to. Once you get the hang of this, you can kind of just do it and then write your answer. That's fine with me as well. All right, balance everything except the oxygen. So we have 2 irons, 2 moles of iron. We need 2 moles of iron. We have 1 mole of carbon, 1 mole of carbon. Check. That was step 2. Done. Right? Okay, add water to balance the oxygen. So notice we have 3 oxygens here. There's no oxygen over here. So if we add water, because this is an acidic solution, what is the solvent in that solution? What is the solvent? Yeah, it's water. So we're just saying, let's account for some of the water that is going to participate at some level. 1 oxygen, 3 oxygens, so we need 3 waters.
Now I'm gonna add 6 hydrogens on
Okay.
there.
But you see, we have 3 oxygens, so we need 3 oxygen.
So in the acidic solution,
Mhm.
so it's like water with with
Hydrogen.
extra hydrogens.
Hy-
So are
the
those
protons.
hydrogens free floating or
Yes.
are they attached to the water?
Well, they're interacting with water. Yeah. It's actually better to write this. So this is water. This is a slightly negative. If the hydrogen ion comes here, this positive charge will interact with that negative charge and actually form this bond. So they'll actually begin to share electrons. And this is called hydronium, H3O+.
So it does form
Mhm.
stuff.
Yeah, natural ion. Yep. So if we were going to study acid-base chemistry, we actually wouldn't put hydrogen here, we put hydronium. But for the sake of simplifying what we're doing, because that is, H3O+ is hydrogen plus water. And that's what we're going to add in here is water plus hydrogen. So now that we have balanced these oxygens, let's balance these. 2 oxygens here, 1 oxygen here. So we need 1 water, right? 1 plus 1 is 2 oxygens. Go ahead and add hydrogen to balance, hydrogen ion to balance the hydrogen. Okay, we have 6 hydrogen here. We need 6 hydrogen here.
I think
And
you're
why,
right.
why do we add hydrogen ion instead of just hydrogen?
Yeah, because again, it goes back to that. If we take these two, we actually form this. It's better for us just to write this in this equation. But since we're not studying acid-base chemistry, we're going to separate it out. We added our water. Now we have to add our hydrogen ion in there. Good. All right, what about over here? How many hydrogen do we have to add here?
2.
There's 2 hydrogen atoms, so we need 2 hydrogen ions. Are present there. That's H. Okay. Balance the charge. Now, what is the be careful with this. What is the overall charge of the reactants?
Plus 6.
Reactants. Go ahead. Say it again.
Plus 6.
Plus 6. 6 positive charges, right? And over here, the products. What's the overall charge? Neutral. Why? Because we don't see anything here, right? And we don't see anything here. So we need to make these 2 sides charge equivalent. To do that, we have to introduce electrons. If I introduce, don't write this down. If I introduce electrons here, my charge goes to -6. So that's not good.
So we need to take away 6 electrons.
We need to add 6 electrons over here. So now what's my overall charge?
Neutral.
Yep. This side is neutral, and this side is neutral. So 6 positives plus 6 negatives cancel out, and we have an electrically neutral reaction. Okay. What about here? If I add 2 electrons here, is that good or bad?
No. You don't want to do
No.
that. You want to add 2 electrons over there.
So 2 negatives plus 2 positives is neutral, and this is neutral as well. Now, don't write this down, but what if, I'm making this up, so don't write this down. If this was positive, and we go back to here, what would I have added to this side?
You would have only added 4 electrons.
Not 4. Oh, you're right, 4, you're right. Yep, so 4 plus 6 is positive 2. And this is 2 different positive ones, positive 1, positive 1. So now the sides would be charge balanced, and we don't have to go for neutrality. So hear that carefully. You are not trying to make it neutral, you're trying to make both sides equivalent. It just happens to be that this side is neutral, so now we need this side to be neutral as well. So that does come up in there once you get going through this. Okay, so we got this. Now let's go ahead and combine our half reactions and make balance equivalent charges, balance electrons.
And make
So take these 2 reactions, and
It just
combine
says
them
imbalance electrons.
together?
Well, why would you say me?
He was fixing himself.
I'm just gonna rewrite it so we can see it as a next step instead. Again, you don't have to rewrite once you get the flow and the rhythm of everything. All right, now we have to, so we're gonna add them together, and as we do that, we need to balance the electrons. So maybe even, now that I'm thinking of it, this might be like part 1 of this step, and this is like part 2. Sorry. Part 2. Okay, so 6 electrons here. Whatever is oxidized has to be the same number of electrons reduced. We need a common multiple of 2 and 6, which is 6. So if we take this whole thing and multiply by 3, right? The reason for that is we're trying to balance these electrons, and notice those are not the same. If we did this reaction 3 times, would that have produced 6 electrons? Yeah? All right, so let's go ahead and do that. So I'm gonna go ahead and combine all at once. So if you wanna follow the finger, I'll just try to keep it all the same. Okay, that's the reactants from here. I'm going to combine these reactants. So I'm going to do 3 waters, those are reactants, plus 3 carbon monoxides, that's the reactants as well. Okay, you with me? I'm going to go grab the products, 2 Fe and 3 waters. And I'm going to grab these products, but these products are also multiplied by 3. So 3 CO2. 6H plus. I'm gonna, just for today, I'm just gonna label this. You don't have to do it like this. I'll show you where they came from. So this came from equation 1. This was equation 2. Reactants on equation 1, equation 2, and same thing, equation 1 and equation 2. All right, let me stop there. Does that ish make sense? Right, so you balance the electrons, then combine the reactions together. Why are we combining them together? Think about it conceptually.
Because they're all together.
Yeah, it's in a beaker. The reaction's occurring. You don't do this and do this. It's all together. So this entire thing is occurring. Now we're ready to cancel out similar things, if you will. Notice 6 electrons show up on both sides. That's fine. 6 hydrogen ions show up on both sides as well. What else can we cancel?
3H2O.
3H2O. Anything else? Nope. So just write whatever's left over. Okay, so we have this reactant plus this reactant produces 2 Fe plus 3 CO2. So the question is now, back to Gloria's original question, which is a good question. Couldn't we have just balanced that? Yeah, we could have just balanced that. However, did we know that at the time? No. So watch, don't write this down. What if, hypothetically, this would have come out to be like 8H plus? What would be left over down here?
Also the 2 hydrogen.
Right? We would have been able to cancel 6 with 6, but we would have been left over with 2 hydrogen.
But with
If-
our process, don't we have to make them even?
Not the hydrogen ion, the electrons.
Oh.
Yeah, we're just going on a hypothetical, if we still had 6 electrons somehow canceling with 8 here. If we have hydrogen here, what has to show up over here? Yep, so what's gonna carry our hydrogen for us? It's water. And if we had 2 hydrogens and 2 hydrogens, then the entire equation would look something like this. Yeah, we haven't balanced the oxygens, but would look something like this, where we have some leftover water, some leftover hydrogen ion. That doesn't show up here, so if we would have just tried to balance this, and we would have forgotten about the water and hydrogen, we would have been in a totally different state.
Man, this is a pain to cancel, dude. Oh, just one. Oh no.
Doesn't it, since we know it's in the acidic solution, why do we need to include that it's in the equation anyway if it's already there?
Because it may not actually be showing up in the overall reaction, meaning participating.
Okay,
Right.
but if it is participating,
Then it'll
it
show up,
should be.
yep. So again, in this one, the hydrogen ion is there to help carry the charge density, and by density I mean the positive nature of this side of the reactant. Would this have been reduced if that positive wasn't there to help carry those electrons through the solution? It's called a salt bridge. Salt bridge. Okay, let's do the basic solution one.
I want to remind you we're on
Number
yes.
2.
We got time.
Number 2.
Yeah, we can do basic.
Wait, I do have a question.
Yeah.
So, for the part where it says if in basic solution add OH to cancel H plus and form H2O and cancel the remaining H2O,
Yeah.
after what step are we supposed to do that?
You can do it at the end. You can do it right after you balance the charge. That's fine. So if we add hydroxide to cancel out the hydrogen ion, and then we balance whatever's left over, I believe we should get to the same spot. That's what we did. Okay. All right, let's break it apart. What do we put? CO goes to CO2.
And
I2.
goes to I2.
Balance everything except oxygen and hydrogen, carbon,
And add
carbon,
water.
iodine, two iodines, two iodines. Now we're ready to balance our oxygen. We have 1, we have 2. We need to add 1 water. We have 5, so we need 5 waters. Balance the hydrogen. We have 2 here. So we need 2 here. We have 10 here.
Mm-hmm.
So we need 10 on the other side.
Okay.
Okay, let's pause there for a second. All right, so far, not too crazy. Separate, balance all the atoms except hydrogen and oxygen. Balance with water, balance with hydrogen ion, both sides. Now we're ready to balance the charge. Neutral, positive 2, 2 electrons. I'm gonna draw a line so we can keep track of that. We have a positive 10, we have neutral. Again, if this was positive 5 over here, you would have to make this side positive 5, right? Vice versa. But since it's neutral, 10E. All right, now what?
Balance electrons.
Yep. Yep. So we're here, ready to balance the charge, balance the number of electrons on both sides. I think we could do this kind of without having to rewrite everything. So there's 10 electrons here. This needs to be multiplied by 5. Now let's combine it together. So are you okay if I take these reactants plus these reactants and group them together? So this would be 5H2O plus 5CO plus 10 electrons plus 10 protons plus I2O5 produces, I should have started way over there, CO2 plus 2 protons plus 2 electrons, oh sorry, 5 protons, 10 protons, 10 electrons.
Wouldn't it be 5 CO2?
Yep, thank you. I didn't put that there either. Good night, Morgan.
I was like so confused. I was like, we only multiply the hydrogens for like.
Yeah, so 5 waters, 5 COs, 5 CO2s,
Okay.
5, 10, 10, I2O5, 10, 10, I2, plus 5H2. Okay, so that was just combining reactants and products together. Let's cancel. 10's cancel. That's a good check. Actually, you might put that in your notes. If you get to your final answer and your electrons have not canceled, you've done something wrong. At that point on, it's all wrong. So your final answer, no electrons have to show up. What else can we cancel? Hydrogen ion, anything else? 5H2O, right? Like this, and now what? Right, what's left over? Yep. And then now, last step, or last steps. Go ahead and add hydrogen, hydroxide to cancel the hydrogen ion. Do we have any excess hydrogen ion left over? Nope, so we're done. That's it.
So if we did,
But if we did, so again, hypothetically, if we had something like this, you would now have to add a hydroxide. If you had 3 of these, you'd have to have 3 hydroxides. This makes 3 waters, and now your entire equation would be 3H2O plus 5CO2, so on.
oh, so you can combine. You have to put the H2O on the other side though? to cancel?
Okay, tomorrow we'll practice